Hello and welcome to this video about knowledge graphs and topical maps. My name is Mark Möller, and in this video we look at how knowledge graphs are created and how they can impact your website. You will also learn a few ways how you can visualize knowledge bases such as Wikipedia. Let's dive right in. Let's first talk about what a knowledge graph is. A knowledge graph connects the entities, also called nodes, through relationships, also called edges. You can see here we've got the entity Elon Musk, and that is connected to South Africa with a confidence level as well. So whenever Google is looking at text on websites, it might be checking if that's already an existing entity and relationship in their knowledge graph. And if not, it might be interested in adding it to the knowledge graph. And that's where the confidence level comes in. Let's open up SEMrush here and have a look at what their blog says about knowledge graphs. So we have this example here from SEMrush's knowledge graph about J.R.R. Tolkien, the author of Lord of the Rings. You can see here that the edge is connecting the two nodes, J.R.R. Tolkien and Lord of the Rings, with author of. And then you can also see that Tolkien was born in South Africa, or Bloemfontein, which is the capital of South Africa, and died in Bournemouth, which is a town in the UK. So this way Google can basically group or map the whole internet, and you can see why this is important, because what you're trying to do with a topical map is to match what Google has in their knowledge graph to your business and talk about all of the important entities and edges that exist for your topic. There are some fantastic ways to actually visualize knowledge graphs. So you've got Wikidata, which can be visualized through this link here. It's the Angry Loki Wikidata Graph Builder. And you can see it traverses through specific properties of whatever Wikidata entry you're looking at. What that means is that you can't display all of the relationships in Wikidata, but specific subclasses, for example, you can go through. So here we're looking at a museum, and then we can see that there are lots of different types of museums, like the French National Museum, Italian National Museum, and so on. This one here is a little bit crowded, so it's a bit hard to read. But let's say here, if you're looking at a zoo, then you've got all the different types of zoos in there: petting zoo, animal theme park, zoological park, and so on. So that is pretty cool. Another way to visualize things is with the wiki graph. This is not a knowledge graph. This is a knowledge base visualized. And you can see here for the topic of drinking water, you can see all of the Wikipedia articles that are connected to certain topics. So if you are writing about drinking water, you might also want to cover things like water supply, water source, water pollution. I'm not saying you need to cover all of them, but it's more to trigger in your mind the topics that could be interesting, and consider the distance from, let's say, if you are talking about drinking water and you're talking about luxury water, then of course the distance from drinking water to luxury water is relatively small, let's say here. But at the very top here we have fecal coliform in this graph here, and you can see that is quite far away. So you definitely don't need to cover that in your topical map because it's not related, but it's just a way to show you all of the possible topics that you can cover. And then it's your job to find out, right, what's the distance from drinking water to fecal coliform, which I guess it's a bacteria. Yeah. And look, in some ways, you wouldn't want to probably write a whole article about it, which goes into the concept of how big something in Google's knowledge graph is and how big it should be on your website. So if you cover something on your site and you only put it into a paragraph, let's say you say something like drinking water should be clean, and if companies are filtering wastewater, then they need to worry about this bacteria, fecal fecal coliform, you can put that in one paragraph, right? So even maybe just one sentence, versus the other option is that you can make a whole page about it, where the whole page covers the topic only of fecal coliform, and now it becomes the title rather than just being a sentence or a small part of the site. So you can see here, if you create whole pages about a topic, then you're signaling to Google that this is a very important topic and it's directly connected to the main topic that you are writing about, which again, if we take luxury water, that would not need to be its whole separate page, because there would be other topics that are more important. Cool. So I think this is best explored by yourself. Type in your topic that you're interested in. One cool topic that I found here is family law, for anybody who's writing for law firms. Gives a few good examples. So when people are talking about family law, divorce, and so on, then it's important on your side to cover the divorce law in that specific country and perhaps even state that you are writing about. And then I believe this is here in Australia. There's the Family Law Act of 1975. If you're writing for Australian family law practitioners, you definitely want to cover that, because any case that would go in front of the courts would be covered under this law, essentially. So another way to put it is, if you are talking about a topic and you can't talk about it without mentioning these facts or entities, then it's important that you make that part of your sitemap, and it's just a question of how big of a part it should be. Cool, I hope you enjoy exploring these Wikipedia graphs a bit. So the visualization for Wikipedia that we've looked at is on blindpete.github.io. There's also other ways to visualize knowledge bases. These are all not knowledge graphs. That's why I've put that at the top, not a KG, but these are knowledge bases. I've got one video on this channel where we're looking at clustering keywords with search caret. Again, not a knowledge graph, but still a really cool way to visualize all of the topics that your clients are talking about or that your customers are interested in. And that's then also a way to adjust your sitemap to make sure that you're talking about those topics where there is a lot of search volume and a lot of interest in a bigger way, rather than having that just as one paragraph. You definitely want to expand those big topics into separate pages. And maybe here we're looking at fees. Fees seem to be a big topic. Maybe you want specific sub pages for fees, maybe fees for luxury houses, fees in Sydney, fees in New York, and so on for buyers agents. Cool. Now let's check out how knowledge graphs are created. So it all starts with text. It starts with the entity extraction in text. We've got one sentence here. Michael Jordan played for the Chicago Bulls. And Google then reads this text and tries to look for the entities in the text. Michael Jordan is a known entity to Google. And then the relationship is established, which is played for. And then the other entity in here is Chicago Bulls. And relationships always go two ways. You can also say that Chicago Bulls had a player called Michael Jordan out of that. So it's not just a one-way relationship, even though in our graphs we usually display it as that, but it's usually two ways how this data can be queried and arranged. These are also called SPO triples. That stands for subject, predicate, object. And it just refers to the fact that usually in sentences, Google or in machine learning, we look for triples as they are found in one sentence together. The next step, once we extracted the entities, we're looking at entity linking, where we're looking at the knowledge graph and we're asking ourselves, is this a relationship that we already have in our knowledge graph or not? And then if we have it already, then what's the likelihood that this new source basically gives us a more accurate relationship or representation about that thing? So that goes back to the concept that there can be confidence scores assigned to knowledge graph relationships. How confident are we that Elon Musk was born in South Africa. And if we found that information on Forbes.com and on Wikipedia.com, then we can be quite sure. But if it's a new knowledge graph entry and it was on a low authority website, well, then Google would most likely not enter that with a high confidence score into their knowledge graph. It would basically wait for a high authority website to cover that topic to update that authority or confidence score. All right, so then we're looking at relationship extraction. Once we have found which entities in our existing knowledge graph we want to link that to, that's where we can connect it in our knowledge graph to make sure that Chicago Bulls and Michael Jordan are connected together with the relationship of played for. Cool, and the last step is reasoning. Now that we know that Michael Jordan has played in the NBA, let's say we found that snippet in one text, and we also know that NBA is a type of professional basketball league. Let's say another article has covered that. Now we can put two and two together and say that Michael Jordan is a professional basketball player, even though that as a fact in itself we haven't found anywhere. But through reasoning, that is definitely something that Google can do in order to have confidence on questions that Google is answering through the knowledge graph that can appear in search results. So a few more exciting open source projects as they relate to knowledge graphs. Not all of them here are knowledge graphs, but DBpedia and Wikidata certainly are. Yago is a knowledge base derived from Wikipedia and WordNet. And WordNet in itself is a lexical database of English vocabulary, and their synonyms. And WordNet basically maps the words into the vector space, meaning that each word has a specific location on a graph, and this way you can basically graph the relationships and the closeness of them together. So now, how do knowledge graphs really impact your topical map? We've got two opposing goals here. On the one hand, you want to rank and get clicks, which is usually easier for low difficulty keywords. And on the other hand, you want to represent knowledge on your website that matches Google's knowledge graph, meaning if Google has a node on their knowledge graph, and that's very important, and that's within the topic that you are covering, so that's something that relates to your business, then you need to cover that as well. And that's where the problem arises, where a lot of SEOs feel uncomfortable writing about topics where they don't know that they can rank for it. And that's why they just shy away from that topic altogether. But by not writing about that topic, you're basically just covering the very outer edges, and your topical map is never complete. So if we stay with the topic of family law, for example, if you only have pages about family law, maybe family lawyer plus small town suburb, you can then see that essentially you're missing quite a bit in your topical map because you have not covered the Family Law Act, which would apply if somebody needs to go to court. You have not covered the assets that people usually need to split up and how that works. So you're missing out a lot of things if you only go for the low difficulty keywords. And that's where I suppose the conflict lies, that you need to pick the keywords that have the right difficulty as well, because it's also incorrect to choose keywords where you have no chance of ranking, because the average rank of a website is also an important factor, meaning if all of the pages that you've created only rank on page 90 or on position 90, then you'll never actually get clicks to your website, and Google can never validate that your website is a good resource and that it helps users. And that will hold you back as well. So that's why it is a balancing act of picking the topics that you think in time you can rank for them, at least in the top 10 ideally, so that you will get some clicks, and the topics that are just easy to rank for. So you definitely want to have a balance there. So we've talked about the different nodes, such as Elon Musk, for example. That would be a node in the knowledge graph. Drinking water is likely also a node or entity in itself in the knowledge graph. And now the question is, how does one node become important? Because we said we want to touch the important nodes in our topical map, of course, only as they relate to our product or website. And the importance could be derived through the attributes that Google has on a specific node. If we stay with the Michael Jordan example, Google knows his height, his job, his spouse, parents, products, brands, net worth, and much, much more than that. And that can signify an importance. So if you wanted to talk about basketball or Michael Jordan in particular, these would be things that you would want to talk about. And then another part is the text on a specific entity on the internet, meaning if there is a lot of text on the internet, there can be more entities extracted from it and more relationships. We've looked at that previously, where we've seen that there is a text and then we extract the entities and relationships from there. So essentially, the more text there is on a topic, the more entities can be extracted and the more relationships could there be. Probably also the more research you would need to do in order to make sure that you cover a topical map in a lot of detail. And then lastly, we have the search volume for a specific topic and the public interest. So really it starts with the public interest because people are interested in Michael Jordan. That's why a lot of press releases, news are created around it, video content, and text on the internet, and from that Google then extracts the entities and relationships. So really, if we go back to the first principles thinking, then it is the public interest in a certain topic that sparks the whole process and gets it started, and that would actually define what important nodes are. There are also a few principles or mathematical techniques how we can determine the importance of a node. One of them is simply the degree of the number of connections. So we've talked about Michael Jordan, the number of people and associations and brands and products that he's connected to is extremely high. So we would say that Michael Jordan in general is an important entity in the knowledge graph. And therefore, again, if you wanted to talk about, let's say, the history of basketball, right, then he would be quite a big node in there that you want to cover. Then there's also the eigenvalue, which is a mathematical calculation essentially, which looks at how many connections there are to significant other nodes. So we wouldn't be counting connections to very small nodes. Let's say Michael Jordan's dad. There's not that much interest in Michael Jordan's dad, his father, which would be a smaller node. So that would be not an important connection. But other people like Scottie Pippen or Chicago Bulls, he's connected to these other topics that have a lot of significance due to their public interest. Then we have the CUTS method of basically calculating the knowledge graph centrality, which looks at the significance of the nodes it is connected to. So also talking about the significance there, but the calculation is just slightly different. And then closeness. How close is Michael Jordan to other important topics? So we've looked at that proximity or closeness previously, where we had the drinking water and then the fecal bacteria. How close are those topics? That's also something that can help us to determine how important a node is. And then the betweenness talks about, you can imagine a road where you've got lots of different other roads going through and coming out of it. So an intersection where essentially you need to go through this area in order to get somewhere else. And that's another way to think about it if you want to talk about, let's say, water and the human health, then you also need to talk about drinking water, for example, the water sources, and the human body's water value. How does the body store water? So that's another way to look at it, to go, okay, I want to talk about this topic, but to explain that topic, what other things do I need to go through in order to explain that topic well, and what other entities are needed there? And then something that relates to backlinks and centrality would be the PageRank algorithm, which Google is not using for knowledge graphs, but still interesting to know that this is all related, and some of the similar concepts could apply to knowledge graphs as well. All right, let's close off with a few knowledge graph facts. So knowledge graphs exist in English only, and all other languages are then translated back to English, which helps with consolidation. It's just too much work to maintain 100 or 50 different knowledge graphs per each language, because they mainly contain the connections and definitions about certain topics. It's not needed to have them in all different languages. Also because they are supposed to represent offline facts or real life events or connections. And that's why it's sufficient to have one language and then translate it as needed back to that source language. I would also say that in the age of large language models, so ChatGPT, knowledge graphs are still necessary and needed because they offer better accuracy and are also cheaper to maintain. So if you imagine that you try to build a knowledge graph just from a large language model, which has hallucinations, that would most likely not be possible. Cool. I hope you found this video helpful. In the next part, we will dive into actually building a topical map for a law firm. I hope you enjoy that one. I'll see you there.